today is our applications of linear equations. So we got through and we set up and solved our stuff last week. Today we're actually going to be taking and going through and setting up some more that are a little more applicable to real world stuff. Now our first couple are a little bit of review from last week, but then when we get down to the last two, that's where we're going to come into a little more real world situation. Okay, so our first thing, once again, going through and breaking down our word problem, what is the first thing you always want to look for? Is. What does is tell us? That is always our equal sign. Okay, so we can break that off and help us out there. That's our equal sign. So we know automatically we can see real easily we're going to have equals what? Equals 86. Okay, so let's go back to the rest of our problem. 3 times a number decreased by 16. Okay, how am I going to do 3 times a number? 3x. So 3x decreased by 16 minus 16. Very good. So we have our equation here. 3x minus 16 equals 86. Find our number. What would be the first thing we do here to go through and solve? Very good. Add 16. Okay, so we have 3x equals what? 102. And we divide by 3. X equals, what did you say? 34. Very good. Okay, so we set up our equation and then went through and solved. Okay, let's go ahead and come on down. Okay, 4 times a number increased by 9 is equal to 15 more than the number. Find the number. So what are we looking for here? Is. Now is it just is this time being our equals? Is equal to. It says the word equal there. That makes it quite a bit easier even. So we have equals there. Let's go back to our start. 4 times a number. 4x increased by 9 plus 9 is equal to 15 more than. What is 15 more than? Plus 15 or 15 plus? Plus x. Very good. Okay, 4x plus 9. I'll rewrite it over here. It gives us all together. 4x plus 9 equals 15 plus x. Very good. Okay. So, what is the first step that I need to do in order to start solving here? Get our what together? Get our x's together. How are we going to get our x's together? What do we need to do to x to get it over to the other side? Subtract x. Very good. We always do the opposite. Very good. So if we subtract x, what do we have? 3x. And we bring everything else down. What do we do now? Okay, subtract 9. Those cancel. We have 3x equals 6. And how do we finish that? Divide by 3. So x equals 2. Very good. Okay. Let's go ahead and jump down to 4. Okay. So Sarah has 112 marbles in a jar. Some are red, some are blue. If there are 16 more red marbles than blue marbles, how many marbles in the jar are red? How many are blue? Okay, a lot of information here, right? Okay, so couple things we need to go through and look at here. Okay, so we know that Sarah has what? Okay, so there's some important information there. She has 112 marbles in a jar. Okay, some are red, some are blue. Is there anything necessarily important there for us? Not for setting up the equation, just information. So if you have a big one like this, I like to cross out things that I don't necessarily need. Okay. Our next sentence, if there are 16 more red marbles than blue marbles, how many of the marbles in the jar are red? How many are blue? So what else is important here? There is 16 more red than blue. Okay. Now, do we know either of those numbers yet? No. So we have to go through and figure out how many red and how many blue. Now, most times, if we're looking at this, we're going to do this with two equations, with a system of equations, but we will show how to get it all out of one equation. Okay, so we're going to set it up first as two different equations and basically combine them. Okay, so if there are 16 more red marbles than blue, okay, so my red marbles is going to equal what? 16 plus, since we're 16 more than, 16 plus our what? Our blue marbles, our B. Okay? So our red marbles equals 16 more than our blue marbles. Okay? We also know that there are what? 112 marbles in the jar. And how do we get those with our red and our blues? What would you have to do with our red marbles and our blue marbles to get 112? Not times them. Add them. Very good. So our red marbles plus our blue marbles is going to equal 112. Okay, so we've set it up in two equations here. Okay, but we need just one equation. Okay, so the way we can do this, we know that our red marbles equals 16 plus our blue, right? So what can we do with 16 plus our blue? I heard somebody say it. Okay, we're going to put it in parentheses and do what with it? Plug it in for R. Very good. Since R equals 16 plus B, we can just replace those. Substitute it in. 16 plus B equals 112. Okay, so 16 more than our blue marbles plus the number of blue marbles we have is going to equal 112. Okay, now in order to solve this, is there any distribution involved here? No. So what can we do with those parentheses? Do we need to do anything with them? We just can drop them out. Since there's nothing to do on the outside, we can just drop them out. Okay? So now, in order to solve, what do we need to be doing? Very good. Combine your like terms. B plus B makes what? 2B. So I have 16 plus 2B equals 112. Where do I need to go from there? Subtract 16. Very good. So we have 2b equals 96. Very good. And last but not least, divide by 2. B equals 48. So this tells us what? This tells our number of what? Blue marbles. So we know we have 48 blue, 48 marbles. Okay. What about our red? How do we find what our red are?
Plug the B into the B and unplug the B.
We could do that. We could also just plug it in right here. Either one's going to work. You can either subtract 112 minus 48 to get your red, which is what we do if we plug it in here, or take 48, plug it in there, and get plus 16, which either way is going to get you how many? 64. Okay. So we have 48 blue marbles, 64 red. Okay. Questions so far? Okay, we have to use our information to break it down, set it up, and then just solve our problem. Okay, let's look at number 5. It says an electrician has a 60-foot wire. He needs to cut the wire so that one piece is 1/3 as long as the other. What will be the length of each piece? Okay. So, once again, we're looking for how many pieces of wire? 2. Okay. Now, if we make, since we're looking at the length of our piece, okay, if we make x be our length of one of our longer piece, okay, we can look at it this way and have one total equation. So let me ask you this. What do my two pieces need to add up to be? 60. Okay? So I know that whatever they are, they need to add up to be 60 feet. He has 60 foot of wire. Equals 60. Okay? What's the length of one wire? Huh? Okay, 1/3 what? Okay, so one wire will be X. The other wire will be what? You already said it a little bit. 1/3 what? So if I'm saying 1/3 as long as the other, my other wire is what? Is X. So if I want 1/3 of that, how would I write that? Adam? 1/3 X. Okay. So we have X, the length of one wire, plus the second wire, which is 1/3 of the first length, is going to equal 60. Okay, very good. So what do I need to do right now to start solving? Combine those like terms. X plus 1/3 X is what? 1 and 1/3. How can we write that a little better since we're in algebra? Instead of using a mixed number, we would want it as a improper fraction. Very good. So that would be 4/3. Yes. And then how do we get rid of our fraction there? Huh? So instead of dividing by 4/3, we have to do what? Times by the reciprocal. So we times by 3/4, which is our reciprocal, which gets us what? What's 60 times 3?
45.
60 times 3 gets us 180. 4 times 1 is 4, which that reduces to what, Destiny? 45. Okay? You could have also, other ways you could have finished solving that. You could have done cross cancellation. 4 goes into 4 once, 4 goes into 60 15 times. So then 15 times 3 gets us 45. You could have done it that way and solved. You could have also, when we had 4/3 x equals 60, we could have also done what? Multiplied by 3 to get rid of the fraction. So we could have multiplied by 3, which gives us 4x equals 180, and then divide by 4. X equals 45. All three ways, whether you cross-canceled or went ahead and just multiplied by the denominator, all three are going to get you 45 being the length of one piece.
And
So,
you just type it in your calculator, 60.
Yep. Yep. Okay. Are we done? What do we still need to know? The length of the other piece. Okay. So if this one was 45 feet, what does the other length have to be? Very good. 15 feet. How'd you get that? Okay, so you could take 60 minus 45 to get 15 for that length. You could have also taken 1/3 times 45, which is going to get you 15. Either way works, once again. So multiple ways to solve that same problem. Any questions there?